Good morning, everyone. Again, this is Mr. Renato Friolo. For today's video, we will have evaluating functions. This topic is related to the topic that I had presented to you in my first video about relations and functions. So this is about how to evaluate function. For the lesson objective, at the end of this video, you should be able to evaluate different kinds of functions. Okay, there's only one objective for this video. So to start with, we will uh, we will go back to the definition of a function. So in my first video, I discussed with you the definition of a function. So to review, a function is a mapping from its domain to its range so that each element x of the domain is mapped to only one and only one element of the range. So this is what I've said in the first video, that the domain should only be paired to only one range. For every domain, there's only one range. For every input, there's always one output. Function notation is denoted. Most common function notation is the notation f of x. So fx, or it is to be read as f of x. So this example, so we have here the input value which is for x, the input value which is for x, or which is the domain, and the output value is for the range. And the x, the notation f of x, it is always equal to y. So f of x is always equal to y, which is the range. For every input x, there's always the range y, which is the f of x. Notation f of x means the output values for the function f with the input value x. So whatever value we plug in for x, or whatever value we substitute for x, the output should always be the value for y, or the range. We have to remember two things. A function has only one output for every input. Okay? One output for every input. A function can be named by many different letters. So we can name a function by using g of x, h of x, j of x, p of x, and so on. So how do we evaluate a function? I will be presenting to you 5 different kinds of functions. We'll just start with a more simpler examples. Soon, if I have time in my next video, I will be presenting more challenging examples. Okay, so example 1. f of x equals 3x minus 4. You are told to find f of 4. So this function is an example of a linear function. F of 4, the value 4 is what we call the domain. What we need to do with this value is we need to plug in this value to the x in this function. So this becomes, if we are going to substitute 4 to x in this function, so this becomes f of 4 equals, we copy 3. Instead of writing x here, we need to change this one to 4. So this becomes 3 times 4. Then we simply copy negative 4. After substituting the value to the function, what we need to do is to evaluate. So we copy f of 4 equals negative, by the way, f of 4 equals 12 minus 4. So 12 minus 4 is equal to 8. So the value, if the domain for this function is 4, it will give us an output of 8. So if the domain is 4, the output, or the range is 8 for this linear function. So example 2. Given g of x equals 5x over x minus 2. You are told to find g of negative 7. So we need to plug in negative 7 to this function. By the way, this function is an example of a rational function. So negative 7, substitute to this function, that becomes g of negative 7 is equal to, we copy 5. Instead of writing x here, we substitute negative 7. The same thing happens here. It becomes negative 7 over negative 7 minus 2. Then we simplify. This becomes g of negative 7 was 5 times negative 7 is negative 35. Negative 7 minus 2 is negative 9. Since both the numerator and denominator are all negative, so our final answer becomes g of negative 7 is equal to positive 35 over 9. Third example, example 3. We are given h of x equals x squared minus 4x. And you are to find h of negative 2. By the way, this function is an example of a quadratic function because of the exponent 2, quadratic function. So we substitute negative 2 to this function. So this will become h of negative 2 equals negative 2 quantity squared. Since we have the exponent here, we substitute negative 2 to x and negative 2, then quantity squared, we copy minus 4, then we have the x here, we change that with negative 2. To simplify, the square of negative 2 is positive 4. Then negative 4 times negative 2 is positive 3. So therefore, h of negative 2 is equal to positive 12. So if the domain is negative 2 for this function, the range should be positive 12. Next example, you are given the function r of x equals the square root of x minus 1 over x plus 4. And you are told to find r of 5. So we will substitute 5 to x in the function. By the way, this function is an example of a radical function. So this becomes r of 5 equals the square root of 5 minus 1 over 5 plus 4. And we simplify, 5 minus 1 is 4 and 5 plus 4 is 9. Since both 4 and 9 are perfect squares, the square root of 4 is 2 and the square root of 9 is 3. So our range is 2 over 3. But for this specific function, if the domain is 5, the range should be 3. Now, for the last example, you are given a piecewise function. The difference for this function is that the piecewise function is composed of two or more functions embedded in one function. And each of the given function has restrictions. So meaning, we can only allow the domain for each function depending on the restrictions. For this example, g of x is equal to x squared plus 1 if the domain are less than 0. That means the domain for these functions, the allowed domain for this function are those values which are less than 0. So meaning we cannot use values greater than 0 for this function. The same thing happens for the second function. X plus 1, the domains are greater than or equal to 0. So that means values which are less than 0 for this function are not allowed. So you try to check for the restrictions. For example, you are told to find g of negative 3, g of negative 1, g of 0, g of 6, g of 2. We cannot just plug in all of these functions to both functions because of this restriction. So meaning, the values that are allowed for this function, the domain for this function which are less than 0 are only negative 3 and negative 1. We cannot use 0 for this function because this is only less than. Whereas we can use this function for the this value for the second function because of this greater than or equal to 0. Let's try. So the given function g of x is equal to x squared plus 1 if x is less than 0. and x plus 1 if x is greater than or equal to 0. So we have 5 values here. We can only use the first 2 values for the first function and the second 3 values for the second function. So for the value g of negative 3, so we can use x squared plus 1. So we have negative g of negative 3 is equal to negative 3 quantity squared. We copy plus 1. So the square of negative 3 is positive 9. And 9 plus 1 is positive 10. For the second value, which is negative 1, so we have g of negative 1 is equal to negative 1 quantity squared. Same function is used here, plus 1. The square of negative 1 is positive 1, so 1 plus 1 is 2. For g of 0, so again, we cannot use this function for the first function. We can use this value for the first function. We can use this value in the second function. So x plus 1. So g of 0 is equal to 0 plus 1. So therefore, 0 plus 1 is 1. G of 6, same, second function. So that is g of 6 equals 6 plus 1, and 6 plus 1 is 7. Same also for g of 2. So that is g of 2 equals 2 plus 1, which is equal to 3. Okay, so we have that 5 examples. I have presented 5 examples. So for the next video, I will be presenting to you more challenging examples for evaluating functions. But for now, we will just have these 5 examples. And if you have any questions, you can just comment down below your questions. I will answer your questions in my next video. Uh, for now, thank you and God bless.